Okay, I want to talk about graphs of functions. Now, one thing I love to do is throw things. Now, my right arm is kind of destroyed, a couple of surgeries, so I can't throw very well, which is good for this exercise. So what I'm going to do is I'm going to throw chalk at the board. Okay, there we go. There we go. There we go. There we go. And there we go. Okay, so I got 5 points on the board. Now I'm going to connect those 5 points. I couldn't connect them with straight lines. I connect this point to this one, and this one to this one, and this one to this one, and this one to this one. But I want to connect them in such a way that they form a function, that they have only one y value for any x value. Now we're going to have an xy coordinate system here. Let's go ahead. Put x this way and y this way. I got 1, 2, 3, 4, 5 points. We can only have one y value for a given x value. So that, for example, this point here, right here is its x value. Okay, there's no other point on this line, so there's only one y value for this x value. Similarly, this point is on a vertical line. This point is on the vertical line, and where the vertical line crosses the x-axis, well, that's the x-coordinate of the point. So the vertical line here, and the vertical line here. Okay. So we've got 1, 2, 3, 4, 5 x values for 5 points, and all the x values are different. Now, when I connect these, if I connect this point to this point, I can't come back and connect this point because I'd have 2 points on my graph. Okay, my graph goes over here and back here. Then any point between here and here is going to have 2 y values for a given x value. So I've got to connect them from left to right in order. So I'm going to do that, and I'm going to do it. I could use straight lines. Let's put a straight line from here to here, 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 here. But I'm going to use a smooth curve. So here goes a smooth curve. Let's see. I can start the curve anywhere I want to over here. I don't get, let's say the curve is going to this. Here, and then it goes back here. Then it's got to kind of go down quickly here. Got to keep moving to the right though, because we can't violate the vertical line test, which we just did, because this point here and this point up here seem to have the same x value. So yeah, maybe we do a little bit of repair on that. When we get real close to vertical, it's easy to slip backwards. Let's see if we can things going to the right as we go. I don't know if I managed it. It's got to be almost vertical here, and I think it still has a little kink in it. Let's pretend that that's not a problem. Okay. I can't help it that I threw this one way down here and this one way up here without that much distance between them. So let's assume that this function doesn't backtrack anywhere. Okay. So now I'm going to give this function a name. I'm going to give this function, and I'm going to call the name of the function y equals f of x. Now all f of x, well, f of x does a lot of things. You can see that much of it right now. But this is just a way of referring to the function. Okay. And what f is a rule that tells us if we know what x is, we find what y is. Okay. You don't need to worry too much about that right now. We're just going to mainly use the f as a way of naming the function. Okay. So let's put a scale on this graph. Okay, let's say that 16 is up here. Let's put 32 way out here. Well, I choose 16 and 32 because they're powers of 2, and I can then easily create a scale. 16 here, I come down. This should be about negative 16 here, I think. If that's 32, I don't have 32 over here And I don't need this picture anymore, I don't think. The picture's there because we just have a blank board. I can't seem to convince the camera to have a fixed focus, and it auto focuses on whatever it imagines and loses focus as well. But I think this picture will be enough to keep it focused. Okay, so 16's here, -16 should be about here. Now 32's here. I'm going to go halfway from 0 to 32. That's going to be about here. If I get that, and it's a little off, but okay. So if that's 16, this should be -16. And now we can, like divide the interval from 0 to 16 in half, we get 8. 0 to -16 divided in half, we get -8. And if we divide things up in half, if we want halfway between 16 and 32, that would be 24. Okay, so we have a scale. Okay, so what I want to do is I want to estimate. Well, let's just estimate the x coordinate of this first point, or the x1 coordinate. Okay. Well, the x coordinate corresponds to this. So this is -8. If I cut this in half, and that would be like -4. Cut that in half, it would give me about -6. That looks like about -6.6. Okay, so I think that this is a line where x equals -6.6. So that the x coordinate of this point is -6.6. What's its y coordinate? Well, the y coordinate goes over here. Okay, now halfway between 0 and 16, it's just a little below this. So I'm going to say 8 is here. The y coordinate of this point, well, let's see, this is 16 and this is 8, and 12 is going to be about here. 10 is going to be about here. 9 is going to be about here. We're going to say that's about 8.5. Okay, so this line here is the line where y equals 8.5. So the coordinates of this point are -6.6 and 8.5. Now you're probably familiar with this. Might not hurt you to have them reviewed and see some of the other things I'm doing here that you might not be used to. Okay. So right there, the coordinates of this point. Now, what I want to know is what's the value of y when x equals 8? I think you got 8 sitting right here. Oh, well, I want you to stop and think before you see what I do to find the value of y when x equals 8. So pause that video and figure out what you think the value of y would be when x equals 8. Okay, well, the value of y when x equals 8 is the coordinate on the graph. It intersects the line where x equals 8. Well, right here it is. And now we can estimate its y coordinate. Let's see if that's 8 and that's 10. This is about 6. So this little line here is about y equals 6. Wrote that kind of small. So this point would be the point 8.6. But we say that when x equals 6, sorry, when x equals 8, y equals 6. Okay. Another way of saying that is a little more detail. When x equals 8, the value of y equals f of x is 6, because our function is y equals f of x. So f is kind of like a machine that takes 6 as an input and spits out, takes 8 as an input and spits out 6. Okay, you plug in 8 and you spit out 6. Now you're probably familiar with it. There's algebraic expressions for functions. We'll get to those right now. We just want to talk about them in general. Okay, so when x equals 8 divided y equals f of x is 6. This says the same thing this does if you understand a few conventions, but this is a more specific statement, okay? It actually invokes the idea of the name of the function f of x. Okay? Or we could say f of a equals 6, because if x is 8, then f of x is f of 8. 8 is the value of x. So we say f of 8, and the value of y is 6. F of 8 is 6. F of 8 equals 6. So these are three equivalent statements. So what if I want you to estimate f of, oh, let's pick a good one. Okay, well, I'll just say f. Well, again, you should stop and estimate that. Okay. You're gonna say, well, okay, y equals f of 24 means what? Now, if you estimated it, that's great. If not, we'll do a little more explanation to help you along if you haven't made a good estimate. Y equals f of 24 means x equals 24. The value of y equals f of x is f of 24. Okay, because of course x is 24. Well, then since y equals f of x is 24. Well, that should be obvious, but let's see. Now, the value of y equals f of x is f of 24, and from the graph, we can sketch the line for x equals 24. Find the point on the graph and estimate the y coordinate of this line, which we do fairly easy. 16 back to 0. Negative 8 should be about here. Halfway between 16 and 8 is 12. Negative 12. In this case, that might be negative 12. So this could be negative 10. I'd say negative 9.3. Just my estimate. Y equals 9.3. It's approximately equal to 9.3. We'll worry about that too. Okay. So the value of y equals f of x is f of 24 equals negative 9.3. You see what I did? I didn't put my negative with this because I got something up on evaluating the numbers. Okay. Y is negative 9.3 at this point. X is 24 at this point. Okay. Now there's one more thing we want to be able to do. We want to be able to evaluate x for a given y. Now, since we have a function, only one y value for a given x value, we can only have one value of y for a given x. However, we can have multiple values of x for a given y. So let's just say that don't want to use the value. Okay, should have planned this out better. But I'm going to say, okay, let's go with y equals 3. So if y is 6 here, then y is 3 up here. And the line y is 3. Be about here. So our question is, what are the values of x if y equals 3? Now, sometimes there's just one value, sometimes there are many values. That's why we put the S in parentheses. In this case, right here is an X value that corresponds to Y equals 3. Here's another one. Here's another one. And it looks like maybe we hit 32 in that. Okay. Okay, well. X, I'll say approximately, a little wavy. You can find that. Approximately, well, that's -4, that's -6. I'd say -4.7. X approximately equal to, it's not negative, I don't know why it's negative there. If that's 8, that's 4. So 6 would be there. I'm going to say about 7. Make that negative sign into 7. Okay, over here, there's 8, there's 16. Halfway between 8 and 16 is 12. Halfway between 12 and 16 is 14. So 13 would be here. So I'm going to say about 13.3. Now, if you made estimates and you know your estimates aren't the same as mine, that's perfectly okay. First place, you don't have the board to write on. Second place, my estimates are probably on. And X equals 32. Now, what we say is these are the solutions of the equation Y equals f of x equals 3. Now we could just abbreviate that. If you understand that y equals f of x, we could just say equation f of x equals 3. So what we've seen so far is how to find f for given x and how to solve an equation f of x equals some other number. So we've estimated f of 8 f of 24 and solutions of f of x equals 3. Now, one exercise you're going to say is, I'll give you the coordinates of maybe 5 random points and ask you to do a similar exercise. Okay, ask you to estimate f of whatever value, y of whatever value, and solutions of f of x equals some number. So this is the language, and this is how we do it. Now, not going to expect you to be an expert at that right away, but there will be an exercise where I see if you've seen how to do this. And of course, we'll work on it in class as well.